Hello, my name is Brady Yang. The date is June 10th, 2025. I'm a junior at Peyton, and this is a project for my AP Calculus AB class. So today I'll be teaching you what L'Hopital's rule is. L'Hopital's rule was named after 17th century mathematician Guillaume de L'Hopital. There's a picture of him in the bottom right corner. And this rule is used to evaluate limits that result in an indeterminate form. For example, 0 over 0, infinity over infinity, or negative infinity over infinity. So, L'Hopital's rule states that if the limit of x to the a of f of x over g of x, these can be any functions, gives you a result of 0 over 0, or infinity, or negative infinity over infinity. So these are the indeterminate forms that we were discussing. Then the limit of x to a of the f of x over g of x is equal to that same limit, but instead now we have the derivatives of these two functions. And then the important thing is that L'Hopital's rule requires that both of these functions, in this case f of x and g of x, they must be continuous and differentiable on the interval that you're looking at. So let's look at a mild problem. So say that we have, as the limit x reaches 0, negative 12 sine x plus 10x divided by negative 5x plus 9 sine x. So the first thought would be to plug in 0 to get an answer. So we plug in 0 for x here in the numerator, and here in the denominator. And then after some arithmetic and simplifying, we find that this answer gives us 0 over 0. Since this is an indeterminate form, we can use L'Hopital's rule. So by applying L'Hopital's rule to this problem, we have to take the derivative of the top and bottom functions. So then this gives us, for the numerator, our new numerator, negative 12 cosine of x plus 10. And then our new denominator is negative 5 plus 9 cosine x. So now we are finding the limit as x goes to 0 for this new function. So now we plug in 0 again. This time we plug in 0 here and here. And after some simplification and arithmetic, we get the answer negative 1 over 2. Therefore, since we followed all the correct steps and requirements to L'Hopital's rule, we can say that the limit of x as it reaches 0 for our original equation, negative 12 sine x plus 10x divided by negative 5x plus 9 sine x is equal to negative 1/2. I'll give you guys a second if you want to take a look at this problem one more time. Okay, so now let's go over a more difficult problem. This problem will show you how just because you can use L'Hopital's rule doesn't mean that it'll give you a definite answer after the first use. So for this problem, we're looking at the limit as x reaches 0, sine of x minus x divided by x to the third power. So similar to last problem, the first instinct would be to plug in 0 and look for an answer. So we plug in 0 here, here, and here, and after arithmetic, that gives us the indeterminate form. So similar to last problem, we can use L'Hopital's rule here. So we take the derivative of the top, sine x minus x, and the derivative of the bottom, x to the third. So then our new equation is the limit as x reaches 0, cosine x minus 1 divided by 3x squared. So we plug in 0 here and here now, but as you can see after we simplify, it gives us the same 0 over 0. So now would be a point in time in which many students would simply say, I guess L'Hopital's rule doesn't work here because it would just give us another indeterminate form after supposedly it should fix that. But just because it gives us the indeterminate form again, that actually means that we can use it again. So we apply it again. We take the derivative of our previous equation, which was derivative cosine x minus 1 divided by derivative 3x squared. So now our new equation is the limit as x reaches 0, negative sine x over 6x. But once again, we get 0 over 0 for our answer. No problem, we can use that again. Derivative of our of our previous negative sine x divided by derivative of our previous 6x. So now we have the limit as x reaches 0, negative cosine x divided by 6. And what do you know? We plug in 0 here, and we get the answer negative 1 over 6. As a result, the answer to our original problem, what is the limit as x reaches 0 of sine x minus x divided by x to the third, is negative 1/6. Thank you.